Okay, class, let's take a look at these problems. The first one I got on my quiz was a toy rocket is shot vertically into the air from a launching pad 8 feet above ground with initial velocity of 40 feet per second. The height is h in feet, and the rocket is launched above the ground given by this function. How long will it take the rocket to reach its maximum height, and what is the maximum height? All right, so these are the answers that we'll have here in a minute. All right, so we take a look at that function, and the problem tells us that the height is described in y in terms of h, and that's where the y always goes, and then the x is going to be like the time that we have since takeoff. All right, so because we have this function y and x on the x and y axis, so we're talking about height up here on the y-axis and time would go along the x. So I think the easiest way is to go ahead and graph this. Just type it in your calculator. Okay, so I typed it in there. Be sure to, of course, hit the negative button. Negative 16x squared. You have to type in x, not t, plus 40x plus 8. Now, if I do a zoom, just a standard window number 6, we can see that, yeah, the function comes up and then it goes off the screen and then comes back down. So it's kind of got the parabola shape. And that's what you would expect with something that flies up into the air, would always make a parabola shape. So I'm going to go to my window. This is need to kind of get out of this a little bit. We're in too close. We need to kind of zoom out. But I'll do this manually with the window. Okay, now if x is time, then negatives don't make any sense. So I'm going to make that 0. And then it looks like it went kind of, to the right. So 10 is out here. That might be too big. I might reduce it down to 5 along the x. So let me hit my window and go down to 5. Okay, then y is talking about the height. So a negative height doesn't make sense. So 0 would be ground level. And then we need a bigger y max. I'll try maybe 40. Just picking that number out of the thin air. And if that didn't work, you can always go back to the window, change these settings. The y usually be maybe this number possibly would be a good starting place. So here's the look at the graph. Okay, so it goes like this. Starts 8 feet above ground, comes down, and we have a maximum right up there at the top. All right, so I'll let the calculator do the work for me. I'll go into second calculate, and I'm looking at a maximum value, so that's number 4. And then, of course, left bound would be to the left of that point. So the maximum somewhere up there. To the left would be anywhere over here. Enter. And if you need to pause a video at any time, feel free to do so. And then to the right, this is on the right side of that maximum. So it's looking between those two arrows for the answer. And the answer does exist right there. So it tells me that x is equal to 1.25, around that, and y is 33. Okay, so remember that x is time, so that's 1.25 seconds, and then the height is y, so 33 would be feet. All right, so there is our answer for that one. All right, going to the next problem. All right, so this one's talking about the travelers in the U.S. from the period 1990 to 2009. And it can be modeled by this polynomial. X represents 1990. X equals 1 represents 1991. X equal 2 would be 1992, etc. So we need to figure out how many travelers came to the U.S. in 1990 for the first part. All right, so up here it says 1990 is 0 in terms of x. All right, so there's our function, kind of a long polynomial. But if 1990 is 0, to figure out how many people came, we would plug 0 into the function for every x. So it would look like this. Okay, this is not something I came up with. But sometimes in real life you have a long function. Okay, so basically you go in here and type this in your calculator and get the answer. It's going to be pretty easy on this one because 0 times 0 and then times 0. The answer would be just 46.61. So for the My Math Lab, 46.6 is looking for the 10th place. So you only round it to the 6 there. 46.6. All right, so part B on my problem, it says how many people came in 2000? Okay, so if we start in 1990, how many years later would it be to 2000? It would be 10 years later. So I would type in 10 in my calculator and just plug it in for each x. So this one would look like this one again, our function. Okay, put 10 in where that x is up here. So that'd be 10 cubed plus 0.1174. Plug in 10 for that x, that'd be squared. Then plus 1.390, plug in 10, and then plus that 46.61. All right, so this is what it looks like. Now this is where you need to go type this in your calculator. You're obviously not going to do this by hand. So here we go. I'll type in negative 0.00660. I'm not going to use parentheses on this, but I'll type in times 10 to the third plus 0.1174 times 10 squared plus 1.390 times 10 plus 46.61. Okay, so I'm going to go back and double check that and make sure that looks good. So yeah, I got 65.7. I'm going to round that up. 65.7. And is that millions? Let's see. Not sure it says, but this, yeah, in millions. So 65.7 million people came in 2000. All right, so to get to 2009, again, you start at the original 1990, and you go down and figure out how many years it is from 1990 to 2009. That would be 19. So you do the same thing here, just plug in 19. So you're really just finding P of 19, and type that in your calculator, do the same thing. And on this one, I got 70.1 for the answer. Okay, I'm not going to go through that one, but it's the same as plugging 10 in and then 0. All right, so there's that one, and we have one more to look at. Actually, looks like 2 more. All right, so the next one is talking about population growth. So I'm right here. So the population of a city was 5.93 million. The growth rate is 3.57% per year. On part A, we need to find the function. Part B, we need to estimate the population in 2018. When will the population of the city be 8 million? And then find the doubling time. So there's quite a bit to do on this one. All right, so first of all, I laid out what the function looks like in terms of population growth. P of t is a population after time, after so many years, typically years. So you know t is time. The initial population is this variable p sub 0. E, we know what that is. That's a constant. K is the rate, the growth rate, and then t is, of course, the time. All right, so on part A, find the function. So I need to just go take these numbers and plug them in. Okay, so now K is the growth rate, which it gave me 3.57%, but I don't plug the percent in. I need to plug in the decimal, which would be this. You divide by 100 or move that decimal place to the left 2 spots. So 0.0357 is what I'll type in and put in the function. And the initial population, according to my problem right here, 5.93 million. 5.93. All right, so on part A, my function is P of t equals the initial population, 5.93, E, that constant, and then the rate we said was here, 0.0357, and then t will be the time we can plug in. All right, so that's part A. Let's go to part B. Estimate the population of the city in 2018. All right, so we need to look at this. This represents the time starting in 2012. Okay, so in 2012, that means x is 0, or t, we're using t, so t would be 0. So, and this one, what about 2018? Well, how many years from 2012 to 2018? Is that 6 years? I think so. So we're looking at x equals 6, which would mean t is 6. Okay. So here we go. I'm going to take that 6 and I'm going to plug it into the function I found in part A. So it would look like P of 6 equals 5.93 e to the power 0.0357, and then my 6 goes right there where the t is. Then this becomes a calculator problem. So I'll go to my calculator and type this in. 5.93 times second e, 0.0357 times 6. All right, so I've got 7.3. So that would be our answer, 7.3 million. All right, so that was part B. Now part C, talking about the population of the city will be 8 million in about how many years after 2012? All right, so it's telling me that the population would be 8 million after how long? We need to find what t is, the time. All right, so in order to do that, I'm going to go back to that function on part A. 8 goes where this P of t is, the population. And then our right side stays the same, so now we have to solve for this t up here. All right, so I just do this manually, divide both sides by 5.93 in order to cancel that out. So I have 8 divided by 5.93 equals e to the power 0.0357t. All right, in order to bring this t down away from the exponent, I need to take the ln on both sides, natural log, which is the opposite of e, And what that'll do is cancel these two out. So I'll have ln of 8 over 5.93 equals 0.0357t. So you see now that that got rid of the exponent, got rid of this e. I'm going to go ahead and divide this out. I'm going to say ln of 8 over 5.93 and see what that is. So this turns out to be 0.2994. Okay, and that would equal 0.0357t. And then finally divide both sides by 0.0357. Okay, and then I've got t by itself, and I divide this in my calculator. So I've got about 8.4 would be the answer. After 8.4 years, the population reaches 8 million. Okay, so this would be years. Okay, pause the video, go back and take a look at this if you need to. I know that was a little complicated. Okay, and then the last part is find the doubling time. Part D, that's a lot easier. Doubling time has an equation of this. ln of 2, that's a constant, divided by k. Well, we know what k is. Over there at the beginning, I'll go back, show you, there's k right here. 0.0357, so we plug that in over here. Okay, so then we'll divide ln of 2 divided by 0.0357. So doubling time is 19.4, and that would be years. How long it would take to double the population of travelers to the U.S. So you type that in. Okay, so this video is running kind of long. I've got one more to do. All right, so the last one is talking about profit. It says profit is equal to revenue minus cost. And we have the two functions here. All right, so we need to determine the maximum profit and the number of items that must be produced to obtain this profit. All right, so I'm going to plug in my functions into this formula. Okay, so P of X is equal to revenue. That is 790x minus x squared. Okay, now it's minus cost, so minus all of this cost. 2100 plus 70x. Okay, so I put this in brackets in order to make everyone realize that we need to distribute the negative, the minus to both of these terms. That will cause both of these terms to be negative. Okay, and then we can combine like terms, which be those, rather that one, not this one, the first one and the last one. Okay, I'm going to write the negative x squared first. I'm going to combine these x's. So 790 minus 70 would be 710. And then minus our constant there, 2100. Okay, and this is our profit function. Okay, so I can take this and find on part A the maximum profit. So again, there's keyword maximum profit. You need to look at the graph here. Maximum, it's got to look like this. It's a parabola with x squared. It has the highest point, the maximum there. All right. So one way to, I showed you how to do that on the graph last time. So this time I'm just going to go ahead and do it with the vertex formula. So we learned that, I think, back in chapter 3. So the vertex formula is negative b over 2a to find x. Okay, and a is this coefficient. B is this coefficient. So it would be negative 710 divided by 2 times the negative 1. Okay, so I'll go to my calculator, see what we've got here. Negative 710 divided by, well, that's negative 2, 355. All right, so we must have about 355 items in order to get this maximum profit. All right, now going on to find y, which would actually be the profit because y corresponds again to p of x. All right, so to get y, we just take this 355 when we plug it into the function in terms of x. So that would be 355 squared plus 710 times 355 minus 2100. Okay, so here we go. Negative 355 squared plus 710 times 355 minus 2100. Oh, I'm sorry. Let me go back. Forgot the 0. All right, so that would be 123925. So it looks like about 123,925 for the maximum profit. So I hope that helps. Go back and take a look at this. Pause the video when you need to. And good luck on that quiz. Okay, so you're probably yelling at me here. Yeah, 790 minus 70x is 720. I might have said that and wrote down a different number, but I caught myself here before I ended this video. So nothing much changes. Everything still works the same, but I need to put a 2 down here, and that would change this number a little bit. I've got 720 divided by 2. Those negatives would cancel out. 360 would change that answer, so that goes up by 5. And then down here, I would type in 360 in my calculator for these numbers instead of the 355. Okay, so let me look at that real quick, make sure you can see it. All right, so let's see. If I go negative 360 squared plus 710 times 360, it should be 720 there. Minus 2100. So that changes this answer to 127,500. All right, so sorry about that. I caught myself right before I signed off this video. But this is important to go back and double check things. If you have time, use your calculator when you can. And then do those calculations and look at the graph when you need to. So again, good luck on the quiz. I'll see you guys later.